Dear students, as stated, I am recording this lecture video. Topic for today is strategic capacity and planning for products and services. Like we briefly touched on this topic, capacity is the maximum limit that of products or services an operating unit can offer. So technically is the highest quantity of all the products your company can manufacture, or the highest quantity or the highest number of services your company can offer in a given time period. So this is the structure of today's class, and like I said, I'll be posting a separate assignment where you have to watch those 2 to 3 videos per slide. Yeah, this is the slide. So slide number 3 and slide number 24 as well as slide number 27. So to watch the videos, and there are I think 8 to 10 questions per slide where you have to pick any 5 questions of your choice, write a short summary. And again, when I say short summary, just explain each question in, I will say, 3 to 4 sentences, not too long. But these videos are extremely high importance. I have handpicked these. I have researched, handpicked these, and try to pick the ones that have the best illustration as well as example that is a perfect fit for the topic we are learning. So again, there is a lot of learning out of these. So that's the reason I will be doing it. Yeah. So in this recording, I won't be watching this video. It will be your task, which the instructions will be coming shortly. So yeah, these are the videos in here. Slide number 3. So go ahead and watch this. And again, I think these are very short videos, not too long. Here, yeah, the first video is product oriented. Second video is service oriented. And after watching those, so here there are 10 questions, 7 plus 3. Pick any 5. And again, I will say diversify. Maybe when I say 5, maybe go with 3 of these and 2 of these or something like that. But I won't be very picky. Even if you pick all 5 of these and 0 of these, that's totally okay too. But just try to diversify. Then, yeah, this is the picture I showed. So this is a real layout of a facility. And technically what you are seeing is this whole thing had a capacity of manufacturing 130,000 cutters per month. So that was the maximum capacity. Yeah. So I'm kind of going backward. But yeah, so just align with the definition showed over here. So the definition is the upper limit, capacity is the upper limit or ceiling on the load that an operating unit can handle. So the facility that we had, the maximum quantity we could manufacture in the best scenario, in case customer orders all 130,000 cutters, we are able to manufacture these. So that's the maximum capacity. Yeah. And some items or some important terms that you need to consider while doing your capacity planning is the equipment. And yeah, so again, each of this this is like the top view like a layout of the entire facility, and each of them is divided into section into different departments. So the equipment that is used in a department, here you can see there are 3 machines, then here there are 5 machines, then here there is 1 2 3 4 5 6 7 8 9 10 machines and so on. So each department there is equipment. So while doing your entire capacity planning, you have to detail out, go like, yeah, I always keep saying that you as an operations professional, you should be having that ability of looking or getting a 5,000 level view. So yeah, just consider this is your 5,000 feet level view. So you are looking at the entire facility over here, yeah, entire forest over here, and this facility has several sections. Yeah, so you should be able to deep dive into each of this section, that is this department, and then look into equipment, how much space is needed, and what kind of employee skill is required for if they want to work in this department. Similarly, yeah, once you complete all this, then you go to the next one, look at the equipment, space, as well as employee skill required and so on. So those are the kind of examples you should be looking at as an capacity planner. Moving forward, the goal here is to match the supply and demand. Yeah, so again, it's always about the demand that is coming from the customer, and then you check, go ahead, look at your capabilities of your process, and yeah, check the capacities and see if you can match the demand. Do you have the capability to manufacture or provide the services as per required, yeah, as per the customer, and then you do a thorough evaluation in terms of capacity in this case. 2 important terms to keep in mind are your overcapacity and under capacity. So overcapacity is your situation where your operation costs are too high, meaning Yeah, like you have excess capacity. So say maybe one third. I'll use this example. So 130,000 cutters per month was our normal capacity or max capacity, and if the demand is only for say 50,000 cutters, yeah. So again, 130,000 minus 50,000 is 80,000 excess. So again, that tells my facility is at over capacity limit. So even that's not a good sign. And the second term is under capacity, meaning my capacity is 130,000 and say there is really a big demand out there, and the real demand is say 150,000 cutters or 180,000 cutters. So my capacity is 130,000. That tells I'm operating at an under capacity. Yeah, so that's the situation. In that case, I all my resources will be strained, meaning I'll be working 24/7, running all the machines, equipment, employees 24/7. And even if I run 24/7, if my demand is 180,000 cutters, I'll still be making maximum 130 only because that's my capacity. In that case, I'm running at an under capacity level. So two important terms to keep in mind. Some of the key questions to ask while doing your capacity planning is what kind of capacity is needed. Again, for all the product lines, yesterday even Darshan mentioned they have 11 different product lines, and in this case there were four main product lines. And even though there are four main product lines, again there are the number of variants are almost like I will say it's 145 number of variants in this facility. And for Darshan's case, it's almost like 300 different types of variants. Yeah, so you should know what kind of capacity out of those product lines, which have highest demand, which have least demand, which have highest margin, which has lowest margin. So be ready with that information, what kind, and then how much. Yeah, so again, what is the quantity you are looking for each product line and their variants. So what is the quantity needed, and then when it is needed. Timing is very important. So you should know when it is needed. Do I need tomorrow, or do I need next week, or do I need a month from now, or do I need 6 months from now? Yeah, so these are the key questions to keep in mind. Then a few more additional but important questions to ask is how much will it cost? Yeah, so going back to this example over here, maybe there is this big machinery, it is costing me like $1 million, and maybe there is another machinery, maybe it's costing me like $10,000. Yeah, it's a cheaper one, small grinder or yeah blaster that I have. So yeah, keep a tag of your cost factor, or whether there is a very specialized machinery. Say there is a 3D printer and not everybody knows how to use it, or if there is a laser machine, not everybody knows how to use it. So what kind of skill is needed, and do I have the rightly skilled people who can do the job to perfection? So yeah, those are also a few questions to keep in mind. And then do a thorough risk and benefit analysis. Yeah, identify all the pros and cons of the new capacity you're trying to build, or at least the existing capacity, so that you have better understanding and plan better. Are there any sustainability issues? So like some of the examples Darshan gave, where there are some chemicals which are not authorized by FDA as well as other regulatory bodies. And if your process is going to emit some of poisonous gases or some liquid that gets mixed into soil, and in the long run it kills the trees, vegetation, agricultural, as well as maybe aquatic life if it gets mixed in water. So are there any sustainability issues? And should the capacity be changed all at once or through smaller increments? Yeah, again, this is a big technology decision. Oftentimes, the preferred method, again, there is no perfect answer whether you should go with all at once or smaller increment. Yeah, so each case is different, totally different, and it depends upon situation versus situation. Yeah, so again, there is no perfect answer. So depending upon how it's going, if you have a traditional age old legacy system or a big machinery that is on the floor for 30 years, and I have seen those as well. And again, when I say 30 years, it's not like it's not so every 5 to 10 years they tend to refurbish, get upgrades, updated systems, and so on. So those are the smaller increments. Versus if it is really outdated, 30 years old is too long. In that case, even the technological scenario changes within 30 years. So in that case, do you totally need to buy a newer system? So those are some things to keep in mind. And can the supply chain handle the necessary? And again, if I'm getting a big, like extremely big system, maybe 800K, $1 million, $1.5 million, and those are realities these days. So if you are getting a huge commercial system, and if it is requiring special parts, yeah, or special consumables over a given period of time, yeah, So do you have the right supply chain that can handle those necessary changes? So if you are using a consumable is a part of a machine which is used, like continuously used, and it has a life. Yeah. So again, you keep changing, like a grinding wheel. If you are using a grinder, there is a grinding wheel. It is a consumable because you keep using it, keeps grinding. It gets wear off, and then maybe after a week, after days or so, you have to keep changing them and so on. So can your supply chain handle those necessary changes? And we'll go a little bit deeper in the supply chain topic when we get to the end of this class. There is a special topic on supply chain management. So yeah, these are some questions to keep in mind while planning for your capacity. Other few strategic decisions are the impact and the ability of the organization to meet the future demand. So always remember that uh, the capacity decisions are usually strategic, and again I will reiterate this what I said in the class. So once this word strategic comes into picture, you tend to think for longer term. Yeah, not like you're not planning for tomorrow or a week or a month or maybe few months, but you have long term in mind, and that's when there is a potential of having big investments. Yeah, and again yesterday also there were some mentions of capital expenses, and capital, I mean, one of some of the best examples of the capital is or are the bigger systems, bigger machinery you tend to invest in. And like the minimum number of years you try to utilize is like 7 to 12 years and so on. And again you also calculate for the return on investment. But yeah, you and again those strategic decisions, bigger investment decisions, expenditure decisions, also called as capex, are made based on assuming or maybe getting some information about long-term demand. So only if there is a long-term demand where you can utilize those bigger capital expenditure machines for a longer term to get the most benefit out of it. It will definitely affect the operating cost. So make sure you consider that, factor that within your calculations. It is also so capacity decisions are also major determinants of the initial cost. Sometimes you might need to buy $1 million machinery, but maybe there is it pays off, or there is the ROI, return on investment, is anywhere from 3 to 7 years. Versus instead of investing in big machinery, you might go with 2 or 3 smaller machinery, which will cumulatively cost you say 600K. Yeah, so suppose there is a big machinery that does everything for $1 million, and the payback period is anywhere from like 3 to 7 years, versus you go with 3 smaller pieces of equipment. So instead of $1 million, maybe each of those equipment cost you 200K, and the payback is say 8 years. Yeah, something like that, because it has high operating cost, higher operators are required, more consumables are required, and so on. So do that, balance out the risk and benefits, pros and cons, cost and benefit, and make the right decision. Definitely it can affect your competitiveness. So if you invest in a bigger machinery, which has, which has the best technology and so on, maybe you get the most revenue out of it. Maybe you'll be able to make the parts or provide the service in least amount of time in the fastest way, highest quality, no quality issues, highest throughput, and best efficiency, productivity as well. So in that case, you'll be able to get more profit out of each part you sell or each service you provide. Uh, if required, you can give at a, you can lower your price. So definitely it will affect your competitiveness. And it all, like investing in good quality machinery, even though if it is going to cost you higher initially, it is worth it if if it is if it factors, if you gives that competitive advantage. uh, like maybe the initial cost might be high, but the recurring costs are low, so it will balance out in the longer term. So it definitely helps in easing the management. It can become complex due to globalization, especially if there are some consumables that needs to be procured from international places and so on. It can be complex managing them. Maybe you have to pay some tariffs, extra cost, holding cost, shipping cost, and so on. So you have to keep these things in mind while making the capacity decisions. Uh, a couple important terms to keep in mind, and again I touched this topic in the class as well, are The design capacity and effective capacity. Yeah. So again, going with the same example of this whole facility is a big facility with a capacity of manufacturing 130,000 cutters a month. So a design care. So when I say 30,000 cutters per month, and I know definitely based on all the evaluation for years that this is the maximum capacity I can make per month. So that's my design capacity. So is the maximum, the actual real maximum output rate, our services capacity on operation an operation process or facility is designed for. And the next term is effective. Yeah. So you multiply that design capacity one with some kind of factor of safety, say maybe 0.9, 0.8, and that becomes your effective capacity. So design capacity minus the allowances such as personal time off and maintenance is your effective capacity. So the effective capacity will always be less than design capacity. And some example is suppose, yeah, like one, I mean, one way to look at it is 130,000 is my design capacity, but my effective capacity, considering maybe we don't work on Sundays, yeah. So yeah, that 1 divided by 7, one number of days is taken off. And maybe other way to look at it is we used to run the facility in a 12-hour shift starting from 4 a.m. to 4 p.m. Out of those 12-hour shift, there was a dedicated 30-minute lunch break for the operators, and there were three 15-minute breaks. Yeah, and as per the state of Utah law, we have to give breaks to our employees every 4 hours. So three for 15 minutes. Yeah, that accounts for 45 minutes of time off, as well as 30 minutes. So that adds 45 plus 30 minutes. So it's 75 minutes. So almost 1 hour 15 minutes are gone out of 12 hours. So in that case, my capacity, in that other way to look at capacity. So if I pull a calculator over here, so 12 hours minus 1 hour and 15 minutes, yeah, that's 75 minutes, minus, so let's say 1.25 hour, 1.25 hours. So it's roughly 10 hours and 45 minutes of operating time. Yeah, so that's my effective capacity. Yeah, that's other way to look at it. And similar to what we saw over here, that is capacity decision, even this slide number 9 states the same. Give some examples. Yeah. So again, in terms of, so here is a table taken from the textbook that has columns business and what is the input that goes into each of this business and what are the outputs. So let's check for the outputs for the auto manufacturing. So the key output you are tracking are the number of cars that you are selling per shift or servicing per shift. And like one of the example I gave you for the Hyundai project we did with one of our student here in Orem. So their target was to service 90 cars per day, and per day they used to have 8 hour shift. So yeah, so that's like, yeah, in 8 hours their main output they were looking, or the targeted output was 90 cars per day. So labor hours is one of the input they are considering, and machine or maybe that servicing station hours is one of the thing they are looking at. Similarly, for business that makes steel, output they are looking is the tons of steels produced per day, and the inputs are furnace size. Yeah. So if they want to increase the tonnage of steels per day, they have to increase the furnace size. Similarly, here also for the auto manufacturing, if they have to increase the number of cars serviced per day, they have to either increase the labor hours or increase the number of machines to increase the machine hours. Yeah. So these are the like in general, these are the input output variables for each of these businesses. Similarly, maybe if I'm looking at theater business, the number of tickets sold per performance is the output you're looking for. And one of the key thing is number of seats. Yeah, so that's the capacity you are looking at. Similarly, for restaurant business, the number of meals served per day is the main output you're tracking. And the inputs are the number of tables. Yeah, so again, it's logical, right? I mean, if there is a demand, and if you know customers are waiting in the queue in that, and if you still want to increase the number of meals served per day, you have to increase the tables. Yeah, that's one way to do it. And I will say logically increase the seating capacity as well. So yeah, these are some of the inputs and outputs for each of this business type examples. Then looking at the numerical formula. So again, we learned about the design capacity and effective capacity in this slide over here. Yeah. So again, this design capacity is max output and effective is the realistic output. So you multiply the design capacity with a factor of safety, that is the allowance. It can be 0 0.9, 0 0.8, or depending on each situation. Again, there is no standard rule that it has to be 0.9, if it has to be 0.8, and so on. But yeah, you add some level of allowance as per your whatever your company and the stakeholder management decides, and move forward. So another two important terms to keep in mind are your efficiency and utilization. So efficiency is nothing but the actual output divided by the effective capacity. Yeah. So if I go with my yeah, this example, I'll just copy this over here, paste it over here so that I can refer to these formulae. So in terms of efficiency, so see if my effective capacity that is suppose the yeah, based on the demand, if I'm looking at say 50,000 cutters per month, and while I plan for 50,000 cutters per month, that is my effective capacity, my actual output is only 45,000 cutters per month. Yeah, so my efficiency will be 45,000 divided by 50,000, that is 90%. And yeah, so that's yeah, as per my planned yeah, cutter quantity, that is 50,000. And my utilization, again, the utilization I will always be checking based on the design capacity, not the effective capacity that I am planning for. So my design capacity still will remain 130,000 cutters, and my actual output was 45,000. So in that case, my utilization will be 45000, that is my actual output, divided by 130,000 equals to, yeah, so my utilization was only 30, almost 35%, which is, I know it's very low, but that tells me I'm running at over capacity limit. Yeah, but yeah, I mean, this is how you'll be using the formula. And similarly for efficiency, like I said, see, if I'm expecting a monthly demand of 50,000 cutters, even though my design capacity is 130, my effective capacity, that is, I'm the planning for production keeping 50,000 in mind. And if my actual output was 45,000 cutters divided by effective capacity of 50,000 equals to 90%. Yeah, so that's what I'll be. So this is how I'll be using this formula: efficiency and utilization. And each of them are important in their own ways. So depending upon what project you are working, or what measure your team wants to use, either efficiency and utilization, or maybe it's both of them. You have to keep an eye about what's happening, how we are going. So here, similar to what I said, here is an example. Design, suppose this is a numerical problem. Yeah, so again, this is the design capacity given, that is 50 trucks serviced per day, and effective capacity is 40 trucks per day. Maybe yeah, it's an 8-hour shift servicing trucks, and within that, suppose there is 1 hour of say lunch break and other breaks and so on. So in that case, the real effective capacity the servicing company is planning for is 40 trucks per day in 8 hours. And maybe if there were some other maintenance issues, and maybe servicing of some other trucks took extended time because maybe the right employee was absent on that day, or yeah, there could be multiple issues. So with that, they only service 36 trucks. So the efficiency for that will be the actual output, that is your 36 divided by the effective capacity. It's 90%. And for the same scenario, your utilization is actual output 36 trucks divided by the design capacity. The max capacity the service station or service garage could handle was 50. So it tells you it was only 72%. So yeah, this is how you will be using that formula. Some of the determinants, and I think the next slide has a better example. So I'll jump to the next slide. So the how you to determine the effective capacity. And again, this classic example, I will be moving these. Yeah, I will be using the same thing. Hopefully that is helping you in visualizing and getting the point of what I'm trying to make. So factors to determine effective capacity. Yeah. So again, I'll be using this slide again and again and multiple times, this picture. So always think about these points, yeah, on a higher level. So again, categorize based on facilities, categorize based on the product lines or the service lines you are having and their variants. Then processes, yeah. Some processes might have 3 process steps or 3, yeah, like different machines sequenced. Some processes might have 10, 20, 50, depending on 50 might be overkill, but I've seen some chemical processes or semiconductor processes with yeah, like 20-ish. Also consider for the human factor, also category, also consider for the policies, like environmental policy, health safety, HSC and environment policy, or it can be FDA policy if you are working in a regulated environment like medical device companies. Also look for operational factors and also look for supply chain as well as external factors. And when you deep dive, say let's pick one example, say facilities. So just check how your facility is designed. Yeah. So again, this is my layout of the company I worked for, and again, the way the layout was designed was this is your inventory. So all the incoming inventory gets loaded over here. So there is a system outside where all the trucks stop by over here, transfer, and the material issuer or a material handler takes all that inventory, locks it in the system, places it in the right places, and as required basis, it goes to the right places. Yeah. And so again, I'll be and yeah, second part is the department. So there were like several departments. First is your powder mixing, then is your powder assembly, then is your sintering process, and here is a finishing. So the way the design is, we had designed it for the flow. Yeah. So this is how the flow was. So all the raw materials come in at the inventory area, gets checked in, and then it goes to the powder mixing area, then powder assembly area, then sintering cube assembly area, then sintering press. So again, this is a continuous flow going on over here. And once the sintering process is done, it comes to the finishing. So this is your finishing process one, finishing process or finishing department two, and final finishing department. So again, there was a flow. So that's how that's what I'm talking about. And then location. Make sure the flow of these processes, they are placed very close to each other, so you are minimizing the travel and a lot of hassles. And that's the reason why I didn't getting a layout like this is important. So this is what this means. And also consider for environment. Yeah, is there any smoke coming out during sintering when it gets heated? Extremely high temperature. Is there any smoke coming, or are there any other fumes or other different gases coming out? Are they poisonous? If they are, or if they are maybe not like highly poisonous, but maybe in the longer term, if it might have some effects. So your health safety manager has to stay on top of it, make sure it is within controlled limit, because yeah, the city will be looking into those kind of data. Same is the case with products and services. So I think again this topic was discussed, and I think there were some good questions raised by AJ, and I think there was Kyle also and few more, Tyrell, about the product and service design. So look at what type of product you are running. Yeah, so product mix and then the variance of each, and how you are designed. And again, this is a continuous process. You continually try to improvise your design, make to of the product as well as the processing. You always try to simplify and do convert the raw material into the final product in the minimal number of process steps and with least scrap and so on. So this is how you'll be you'll be determining the effective capacity. Then strategy formulation, the key items to keep in mind is always look for long-term demand patterns. So like I said, if the customer today says, I want 10 parts, so or maybe on a monthly basis, I need 10 parts per week, so 40 parts per month, and all of a sudden they come and say, I want 80. Yeah, so they just double it. Yeah. So in that case, do I have the capacity to increase the capacity or increase the production or product servicing to double? So, and again, if that's the case, then again, if the customer is asking to double the amount of quantity they want or double the number of services they want, is this a one-time thing? Maybe there is some issue, and is it a one-time only, or are they asking for a permanent, like moving from 40 parts per month to permanently moving towards 80 parts per month? Yeah. So keep the long-term demand pattern in mind if you are looking to increase the capacity or modify the capacity. Also look for technology change. So that's what I was saying when I say if there is a machine that is say 20-30 years old, so by that time I challenge that the whole technology in the same processing area has improved a lot. In that case, you might just have to get a completely new system which is fully advanced, fully automated, lot of CNC programs, lot of automated programs, a lot of controls, quality control, repeatability, reliability, verification, and as well as validated product and so on. So are you looking for a complete technology change? Yeah. So again, if you want to permanently double your capacity, say moving from 130,000 cutters to 260,000 cutters, So again, you definitely need to increase the capacity, or maybe within that there is one age old legacy system, 25, 30 years old, and it's not keeping up, lots of breakdowns and so on. In that case, you should be looking at technology change. Yeah, what is the advanced technology machinery they are offering, and how is maybe that advanced technology is costing more, but now because of the advancement in the technology, it can make the double number of parts, yeah, or maybe have least breakdown issues, least maintenance issues. So you should be looking at those as well. Also look for the competitor behavior. Yeah, so what again, it's illegal to directly go or like send people and get information internally. But again, there is a strong concept called as benchmarking, even a part of SWOT analysis, SWOT analysis. Has the last part is uh, opportunities and threats. Yeah, so threat is competitive threat you are looking at, or some other threats that might attack your demand and you lose the business. So competitive, the thing is a is something important you should be considering. And in terms of competitive behavior, like I said, again, it's a very fine, like very sensitive topic. But again, benchmarking is a thing. So officially, I have seen what people do is, either go online, do a Google search, and look for what, like strategies or products their competitor is making. To a lot extent, that is okay because you are doing it legally. Yeah, you are not getting any secret, confidential information. That's the reason why there are things like patenting, copyright, and so on. So yeah. So as long as you're doing it legally, it's all good. But yeah, you have to keep a close eye on competitive behavior as well. And again, from legal sources, it's totally okay. Capacity strategies. Again, three very important: leading, following, tracking. And again, there is a simplified way to look at it, which I'll be talking shortly. So leading is being proactive. Yeah. So in other words, this is proactive. This is less proactive. And tracking is also proactive, but in a smaller steps. Yeah. Baby steps. Yeah. So leading is identifying a long-term need. So suppose the sales department, marketing department, when the management at some point even you guys will be in those shoes as you gain experiences. So suppose the marketing guys, sales guys are in close contact with your best customers, and customers see that the industry trend is looking very solid, very promising. And so far we were ordering 130,000 cutters per month, but the way the industry, oil and gas is increasing. Oh yeah, I mean, I know that's not a reality right now. They are going to getting away from oil and gas. But see, yeah, that's the case. And they say they expect us very strong sales for next 2 to 3 years, and moving from 130,000 cutters per month, maybe the demand will be permanently shifted to 260,000 cutters per month. In that case, I definitely need to double the whole facility. Yeah, further replicate the same thing. So again, I have to work on buying a new area, or yeah, real estate, or maybe lease it and start working on these. And again, doubling this is a big cost involved. Yeah, I mean, I definitely know some of these machineries that were worth 1.2 million. And again, to buy something that high, you need to start your efforts at least 6 months ago. Some of the sometimes the bigger systems, like the vendor company from you are buying, they themselves see that there is a 9 month lead time. Yeah, so you have to start way early. Yeah, other is say some of the smaller grinders, benchtop type of grinders and so on. Those machines, again, some of them are readily available, and some of them within like 2 to 3 lead time. So in that case, you have to literally plan the whole system. It will be a big project in itself, but doing that in a leading way, that is proactive way, is what it means. So if there is a sudden change in demand, permanent change in demand, when you are looking at the long-term prospect of the business, if you see that there is a need to double, and right now also within United States or within Utah itself, there are lots of facilities doubling their capacity. So that's what they are doing, the using the leading strategy. Following is doing incremental, make the adapted change as necessary. Yeah. So do maybe the demand is slightly increasing 150K. So one is like, I won't take proactive actions immediately. On a monthly basis. So month number one, the demand is 135K. I know I'm 5,000 short. So again, I'll do some strategy, maybe increase some capacity, marginal capacity in each of this department. In the first department, powder lab, product assembly, cube assembly, sintering press, maybe increase it by 5 or 2%, 3%, 5%. So, and maybe the next month is 128,000. So I know I don't need excess capacity. I already have it. The next month, suppose is 140K, then make the adjustments. So yeah, so this is more of you are following the demand and making the necessary changes as needed. Sometimes you don't increase the capacity at all. What you do is, suppose for few months initially, the demand was 128K, 125K. In that case, you tend to make 130K and keep a buffer stock. Yeah, that is your safety stock of 5,000, 8,000, 10,000. So in that case, if there is an increase in demand, 135K requested. So we already had that 5,000 of excess part waiting in the inventory. So you can sell off. In that case, you don't have to do any modifications to your process. Yeah. And again, bigger modifications are extremely challenging. It requires a lot of planning, lot of long-term planning, because you're literally dealing with multi-million dollars. Yeah. So that's your following. That is, you make the necessary decisions as you go on the go. Yeah, so you don't proactively think of doubling the capacity or buying or adding capacity to each of these departments, but you make the right call as you go. And tracking is similar to the following strategy, but it adds the capacity in small increments. Yeah, so little baby steps. So in terms of layout or the space utilization, maybe there is a maybe in first month the demand is 130K, second month the demand is 140K. So try to add some capacity over here, maybe start adding overtime on Sundays. But again, this if still the demand continues to increase, say 150,000, 160,000, 170,000 cutters per month. So try to add some machinery over here, utilization factor. And once you hit the limit, then maybe add a facility over here or lease or subcontract contract some of the processes that can be outsourced. But yeah, so that's your tracking policy. So again, it's similar to the following, but you add it in a small increment. So that's the point. Capacity cushion, like I said before, it's nothing but a safety stock. So this cushion is the extra capacity used to offset demand uncertainty. Formula is 100% minus utilization. Yeah, so that whatever the delta over here, difference between here, sometimes it can be 5%. If the variability is high, it can be even higher, like 10% and so on. Just in case there is sudden increase in demand, and if I don't have the capacity, I at least have this cushion capacity, cushion inventory that I can sell out, and customer will get what they are wanting, and they won't go to your competitor. Yeah. So something more is organizations that have greater demand uncertainty typically have greater capacity cushion, and companies that have smaller standard product and services have smaller capacity cushion. Yeah, so suppose in consumer goods like Walmart, I know the population of a city is say 100,000, and I know the milk sale is pretty steady. Those people will be having the milk or any food item at a standard rate. In that case, the demand variability is very smaller. So in that case, I won't be keeping bigger stock of the milks, milk cans and so on. But there are other times when there are some other food items which have maybe month number one they are selling 50, month number two they are selling 20, month number three they are selling 80. So you see the delta from 20 per month to 80 per month, it's 60, right? I mean almost 3 times. So in that case, I will maintain a higher stock so that if there is a sudden increase, I can sell it out and still satisfy the customer need, and they will be happy that I provided them the quantities they wanted in the right time, so they won't be going to the competitors. Then very important steps in capacity planning, and this is the exact similar steps we saw in Darshan's slide also for the NPI and PD. But again, this is in a list format rather than a diagram format. So, or yeah, process diagram format, process flow format. So yeah, step number one is estimate future capacity requirement. Yeah, so again, speak with your sales guys or who are in very close contact with the customers and get an estimate of capacity requirement. So again, it all comes from the demand. So if the sales guy see there is going to be a 25%, 50 or 100% increase in capacity, so make that estimation of what will it take to reach those increased demand in terms of capacity. Then evaluate your existing capacity and facilities and identify the gap. So, from the starting of this lecture, I've been talking that the capacity for this is 130,000. So technically, that number 130,000 cutters per month came from this evaluation. So initially there was no evaluation, and maybe the management decided to know what is the max they can provide to the customer, and that is very important number to know for any corporate. And at some point, when your level of seniority is improved, you are in a higher positions in the short term or longer term, you will need that number as well. So evaluate your existing capacity of the entire facility and each department, and check what and see whether you can meet the increased capacity. So identify those gaps and then identify the alternatives for meeting those requirements. So at first, if there are smaller increments in demand, say 10th, so in 3 months, there is going to be a permanent change in the demand, that is from 130,000 cutters per month, the demand is going to be 140,000 in 3 months, and then that's going to stay permanently 140,000. In that case, before making any investment, try to work on overtime, or try to if you are not working on Sundays, start working on Sundays where you don't have to make capital investments. So that's one. So identify alternatives of meeting those requirements. So that's one of the alternative is utilize the same machines and try to increase the man hours. Then the next one is, if required, if you really need to, even if you do that, add man hours, start working on Sundays, and still you see that you are running short, in that case, conduct a financial analysis. So get some quotations for system, machines, equipment from vendors and do financial analysis and see how soon you will be having a payback. How soon the whole equipment will pay for itself and you will start getting the return on investment. And the number can vary anywhere from 2 to 7 years. 2 years is preferred, 3 years is preferred, 7 years is, I will say, marginal. If it is taking 8 or 9 years, definitely management won't give approval unless it's a must. But again, if there is a strong increase in demand, the ROI and the payback should be smaller, like 2 or 3 years. So do that financial analysis and then access any key qualitative issues. Select the best alternative for a longer term, keeping long term in mind. So again, this term long term is very important. Then once you know, move forward. You put in the project plan, you put in the purchase quotation, explain your case to your stakeholders, the bigger bosses, financial managers, financial officers. They will be asking lots of hard questions. Once you provide all the necessary detail, again, it's all demand driven, customer driven. Once you are able to create a strong case, create proposal, suppose everything gets approved, the money gets paid off, you place the order to with the vendors, and once the vendor deliver the newer equipment system, you install it and implement the alternative chosen. And then once you install, implement, start testing, monitor, make sure you are getting the product quality as per requirement and as well as the quantities as per your plant. If there is any delta, identify the gaps, keep on improving. So that's how so this is the process for capacity planning. Then forecasting. Again, there are two, again, like I say, if you are looking for a strategic capacity planning, so how do you forecast the requirements? So I'll say there should be, if you are getting a new capital equipment, on a bigger scale, and you are going to try to invest in real estate, as well as increase the facility size, increase the number of machinery equipment, high cost machinery. Always keep long term in mind. So again, if you see a permanent change in the level of customers, so again, so for months, if my demand was consistently 130,000 for year 1, year 2, year 3, I was running at max capacity. But now the customer is saying they are seeing a very strong outlook for oil and gas, and they expect a permanent change from 130,000 to 180,000 cutters per month, and that's coming within a year. So be prepared for that. In that case, there is going to be a permanent step change from 130,000, or level change from 130,000 to 180,000. So in that case, once I have that confirmed information from the customer, when they are ready to commit that we are going to buy So again, we definitely need to increase our customer orders from 130 to 180,000. So that is a level change, a permanent level change. In that case, if I have that information, I know I'm in a safe zone. I will, the management stakeholders, sponsors will be ready to sponsor all the capacity increase plan. But if the customer says currently for year one, year two, year three, you have been consistently purchasing 130,000, and for a temporary time period, say for the next 3 months, we are going to need 180,000. So again, that's a time, and then after 3 months, again it will drop back to 130,000. Yeah. So again, that's a short-term consideration. So in that case, you have to work with tactics and strategies to yeah, maybe add capacity on start working on Sundays, add overtime, and maybe try to crank up all the machines all the time, keep them running, keep the facility running 24/7 for 3 months, and just match up for those 3 months, because after 3 months it's going to be back to 130,000. Yeah, so that's a short-term consideration. So again, that variation of added 50,000 is temporary, so 3 months only. So that's what this means. So again, if there's going to be a level change and that's going to be a permanent, you are thinking about long term. So again, you are safe to invest in a bigger capital expenditures. But if the demand increase is going to, that variation is going to be short term, only 3 months, do not go for added capacity, no real estate and so on, because once you invest in a machinery or a real estate, it's stuck. You are stuck with it for forever. Yeah. So again, those are some examples. And then, yeah, so again, what we saw so far is for actual product, a tangible product that is being manufactured. So similar strategies are used for servicing also. Uh, the challenges are the service has to be near to the customer. So suppose there is a solar company trying to install a solar panel. Yeah. So again, the actual servicing will only happen on the day that is planned. All the solar panels, yeah, so all the technicians will come to your home or go to the customer's home, climb up the roof, install the panels. So again, they cannot store that. I mean, they cannot pre-install. So it has to, yeah, so you cannot store, and again, it is near the customer. So you have to check with the customer availability, you have to check with your crew availability, you have to check with the solar panel and the whole integrated system availability, and based on that you schedule a day. It can be 1 week, it can be 2 weeks, 3 weeks, 4 weeks, 5 weeks, it can, but again, it has to be as per the customer convenience. Yeah. So again, if the customer says, well, they're traveling, they can't do, so again, you cannot store that. Yeah. So that's your next constraint, next challenge is you cannot store services consumption, even though you have all the equipment, all the crew ready. It has to be, yeah, you cannot store it. You can't just store a service. And then degree of demand volatility. Yeah. So volume and timing is a thing. So suppose government is offering solar credit, so there is a rush of customers. So again, the volume has increased, but again, the manufacturing from manufacturers from whom you are buying the solar panels and assembling it, see the demand is high. So there is a long lead time of 3 months, 4 months. In that case, you are constrained. And again, time required of servicing, yeah, is also something you to consider. Some of the strategies to keep in mind to offset the capacity limitation. Yeah, and again, that, so this is exactly what I stated over here, long term versus short term. So if the customer says there is going to be a permanent change of, so we are moving from 130,000 cutters to 180,000 cutters for, yeah, after 1 year, and that's going to stay for at least 5 to 10 years. In that case, plan for, yeah, capacity addition, or maybe buy real estate and double up all your capacity. But if that's not the case, so if you don't want to invest, increase the capacity, so that's your limitation. Maybe the demand is going to be temporary for 3 months, only 180,000. So in that case, you can work with pricing, you can work with promotion, you can work with discounting, and maybe shift demand peak periods into slow periods. So yeah, coming back, the last point I'm trying to explain, yeah, the tactical shift demand from peak to periods into slow period. So if the customer says, yeah, like I'll keep the same 180,000 for, in this case, 180,000 for 3 months and then coming back. So maybe you should be trying to increase your inventory and try to overproduce with the hope that when the demand is 180,000, you have inventory to sell out. In that case, you don't have to add capacity. Yeah. So these are some of the tactics you use to offset the capacity limitation. Yeah, again, like this is a temporary. If you see a temporary change in demand, increasing demand, you have to evaluate your existing facility and see if you can do the things in-house or do you need to outsource it. Yeah. So factors to consider while making this decision, whether you want to make it or outsource is available capacity. Are you running at maximum capacity? If yes, then are there any alternative vendors who can make maybe some of the important components and you qualify them, give them order, they will make it for you, you bring it in house, assemble them and give it to the customer. Yeah, in that case, you don't have to add your capacity. Look for the expertise. Maybe there are some specialized processes which your facility is either not authorized or you don't have the expertise. In that case, maybe part of the process can be outsourced. Look at the quality considerations as well as nature of the demand, whether it's permanent demand change increase or it's a cyclical thing or it's a short time and then demand goes back to normal where it was. Costing, definitely you have to keep money in mind, and again check for the risk. What is the risk in case there is a risk of losing a customer or similar ones? So you have to keep that cost benefit analysis. You have to do the value engineering cost benefit analysis. So yeah, these are some things to keep in mind, whether you want to make the things in-house, increase the capacity in-house, or can you do a temporary outsourcing before you make a big decision to increase the capacity. Here is your next slide, slide number 22. So maybe I'll change this. Yeah, I think I modified a few things. So this is then slide number 27 anymore. So this is, yes, slide number 22. Going back to my slide number 22. So please watch these two videos, and again the examples in these videos are very important. In fact, I recommend you to watch these at least couple times, and then there are 10 questions over here. Pick out of these 10, pick any 5. Uh, yeah, answer them in like 3 to 4 sentences, and I'm opening an assignment shortly where you can answer those and get the points for these. But again, I'm least concerned about anything else. The most important thing for me is the content, yeah, the high quality content within these videos to help you understand the, yeah, some the more things about, you know, tips for capacity planning. And these are real. I mean, I have seen these and I'm very sure in soon, like once you graduate, get your dream jobs, and once you go or once you get higher management level roles, this is going to be one important thing. And again, I think in the initial part of this class, when we started in lecture number 2, lecture number 3, I had spoken with lots of students and they mentioned that they want to learn more about what a bottleneck is and how to analyze it and how to look into the detail about and how to normalize, balance out the bottleneck. Yeah. So this video is very important. Please watch these two as well, like at least couple times, and then answer these questions. Moving forward, developing alternatives is things to do that can be done to enhance the capacity management is. There are design flexibility into the system. I think that is very well explained in the videos as well. Take stage of the life cycle into account. Yeah, and again, I'm going to talk more about this topic in the next 2 lectures as well. So again, whether you are in the ideation phase or whether you are in the piloting phase, where you're developing something, testing out. If it fails, take the input, redo the same thing, and find a product that you can sell. So that completes your R&D part, and then you launch it, officially launch into manufacture, and that's when the demand increases. So keep that thing also in the mind. And once the demand increases, then you goes into saturation phase, matures, that's when the product is matured, and the last stage is your declining. Yeah. So let's think a case where you are trying to increase the capacity for a product that is about to be retired. Yeah. So it's in the last stage. In that case, do you really need to add capacity? Because in 5 months or a year is going to be retired. Your customer is saying we are not buying it, we are buying the next version of it. So in that case, there is no need to increase the capacity. So take that life cycle thing into consideration. So that's what this means. And always look for the bigger picture, and always look for longer term. Yeah. So while you're looking into teeny tiny details of each of this product planning, each department, each process, and so on, always look at the big picture as well. prepare for deal with capacity chunks. So again, that's one of my favorite. If you see a variability, always use some kind of buffer, capacity cushion, and during your low demand times, maybe try to overproduce, say up to 10%, 20%, so that you maintain that inventory with the hope that that capacity chunk, extra capacity chunk that you have developed could be sold out in shorter period of time. And again, the I think the Power BI assignment you are solving is all about inventory management, and there is a lot of mention of inventory turnover in that. So the inventory, again, if you have capacity chunks, capacity cushions, or extra inventory, you have to make sure your turnover is still not extremely low increased. You have to make sure it is within limits. Yeah. Then always you should be trying to eliminate the bottlenecks and make sure the capacity is smooth. Try to run at optimal operating levels. And yeah, I think we'll be talking about this in the next two lectures also, when we get into the quality part of it, quality management and quality control. And to choose a strategy for expansion is involved. Yeah. And again, if you are literally expanding your facility size by adding more real estate, as well as more equipment, more, so it has to be done strategic way. And when I say the word strategy, you're looking at the long term. Yeah. And then again, you have seen this in the video as well, but this is what a bottleneck is. So suppose there is one operation that is the slowest. Yeah. So again, yeah, yeah. Yeah, let me try to give you an example over here. Bear with me for just few minutes. So again, coming back, and again, I'll go over here, go to that exact bottleneck thing. Perfect. And half. Sweet, yeah. So yeah, I mean, let's look at the bigger picture for now. So these are the important process steps while diamond manufacturing. So process one, powder mixing, furnace treatment, product assembly. Let's take an example of product assembly. Yeah. So you can see this operator is, so again, in her hand, she has some small aluminum cups in which she is adding some powders. Yeah, powder of diamond, powder of some chemicals, powder of some metal, as per whatever the product designer has told them to do in the right quantities, 1 gram, 2 gram, 3 gram, 4 gram, and so on. So yeah, suppose this is a series of operation. Yeah. So again, in this, for the first operation she's doing is adding first ingredient, and then a second ingredient, third ingredient, fourth ingredient, and then it goes to the next process step. Suppose it is high cube assembly, and say timing element for all of these. Yeah. So suppose this her step one, step two, step three, step four take literally few seconds. Yeah. Then she compacts it and puts in the next high cube capsule assembly process. And if it is taking like 4 minutes, yeah, suppose this one took 10 seconds, 10 seconds, 10 seconds, and 10 seconds. So cumulatively it took like 40 seconds. But the next operation is say 20 minutes. Yeah, again, I'm changing the number, 20 minutes. So again, the number 40 second, cumulative number of 40 seconds is way smaller than 10 minutes over here. So what's going to happen is there are lots of aluminum cans which are filled with the right amount of quantity of powder are going to accumulate, and the number is just going to grow over here, because this is your bottleneck, your slowest process. So in other words, a bottleneck process is your slowest process in your process flow, operational flow diagram. So that's your bottleneck. Yeah. And again, oftentimes it's your bottleneck operation bottleneck process that is your pain point, that's your headache, because everything slows down, nothing goes faster beyond this. So you need to have a strategy to balance this out, where you can match the time for this bottleneck process with the other processes, so that there is a smooth flow. And we are going to learn more about it when you learn about just-in-time and lean operations, and I think in the three lectures from now. But technically, this is your bottleneck process. To give some more context on this part, here you go. Again, this is something that I had displayed in our lecture number 1, as well as I think lesson number 2 as well. So this is your semiconductor manufacturing process block diagram. So here are all the sequence of operations, 14 operations or 14 processes. Suppose this takes 10 minutes per part, and this takes 20 minutes per part, this takes again 5 minutes per part, this takes 8 minutes per part. In that case, this third operation that takes 20 minutes per part is your bottleneck. So technically, the easy way to identify a bottleneck is the slowest process or slowest operation in your value chain, in your processing, that limits the entire capacity. So everything gets slow after, oh, sorry, closed it. Yeah, no problem. Yeah, so your bottleneck process is the process that limits your yeah, or the process that is the slowest. That's the easy way to look at it. And again, if you watch the video, there is a lot more explanation. Yeah, so that's your bottleneck process. Few other important things to keep in mind is your the rate of output or the optimal operating levels. So on your x-axis you are seeing is the quantities you make, and y-axis you are seeing the average cost per unit, yeah, per quantity you make, yeah. And again, in I think there are few accountants in our classes, and they have mentioned about this break-even point and so on. So this is similar to that, but let's focus on the operating level part of it. Yeah, so strictly just say on the x-axis you are seeing the increase. So here the quantity is 0, 1, 2, 3, 4, 5, 6, 7, 8. Maybe this is thousands, maybe this is 5,000, 8,000, 10,000, and so on. So technically you are seeing the quantity here on your x-axis, and on the y-axis you are seeing the average cost per unit. Yeah, suppose this is $1, $2, $3, $5, $8, $10, $20, and so on. So this is your increasing average cost per unit. This is your increasing quantity. So as per this theory, there is always a sweet spot, and that's your goal as a business professional, accounting professional, financial professional. You have to look into operation economics or process economics and try to find a sweet spot that is your optimal output rate, which gives you the least average cost. And this is a proven method. Yeah, I mean, this is a proven graph. So again, there are reasons. Yeah, and again, there are two important things we are going to learn, that is economics of scales and diseconomics of scales. So let me tell you easy way to know which part is your economy of scales and diseconomies of scales, and explain more. So your first half, yeah, starting from 0 until this break even point or your optimal output rate is your economies of scale, meaning as you start producing the number of parts, as the quantity increases, there is a point where this is your sweet spot that gives you the least cost per unit as the quantities increase. Yeah, so that's your economy of scale. And again, the reasons are, you know, for manufacturing any component or delivering any service, there is a setup cost, there is an equipment cost that you have already invested, and you are factoring it over a longer time. So as the quantities increase, suppose my setup, say I have this process photoresist coating, yeah, and each has 4 machines. And again, so again, I have paid for that, my company has paid for that machine, and there are raw materials that I have paid for. Then there are operators who are paid on hourly basis, and yeah, there is some special setup required. So once the setup is done, suppose the cost of setup is $45, and if I make one part, again the setup cost per part is $45. If I make 2 parts, the setup cost per part will be 45 divided by 2, which is $22.50. If I make 3 parts, the setup cost is 45 divided by 3, that is $15. Suppose if I make 10 parts, the setup cost for those 10 parts is 45 divided by 10, which is $4.50. So again, as I increase these quantities, the setup cost per quantity keeps on reducing. Yeah, so that's what this means. So again, that's the economy of scale. So you increase the quantities so that you are countering and minimizing the bad effect or reducing this setup cost part of the portion. Yeah, but again, there is a limit beyond which, if I start still increasing, again the setup cost part component of the costing will keep on reducing. But what will happen is, if there is no demand, there is no high demand. If my say this is, I will say, let's 10 quantity. Yeah, so again the setup cost is going to be 45 divided by 10 quantity over here. So 45 divided by 10 is my optimal output rate should be 10, and the minimum cost I'm getting per part is $4.50. And suppose my demand is also 10. In that case, whatever I'm making, I'm immediately selling it out because that's my demand. Yeah. But after that, if I increase the quantity, my demand is 10. If I increase the quantity, say 11, 12, 13, 14, 15, 16, 20, 100, and so on, definitely my setup cost is going to go low for the in demand product, which is 10. But the extra that I'm making, yeah, so 11, 12, 13, 14, 20. So that 20 parts I make. But if my demand is 10, the remaining 10 quantity, I have to store it. Yeah, so my storage and handling cost, inventory cost is going to go high. So that is going to have a bad effect. Yeah, so in that case, again, my cost will start increasing. So this part of your graph is your diseconomy of scale. Yeah, so I will maybe draw an imaginary line over here. Everything on the left of this imaginary line is your economies of scale, and everything to my right of this imaginary line is my diseconomy of scale. So that's what is explained over here. And again, there will be some questions in the quiz that is associated with this video as well. So yeah, I'll have you guys read it. But that's what I exactly explained. So economies of scale and diseconomies of scale. And even this slide stays the same with some more added information. I will let you guys read it. Uh, the same is the case with this economy of scale. And this is a typical thing which is very, very true for the size of the facility. Again, I have worked for like Fortune companies which were considered as large, but there were times when we had vendors whoever small plants. Yeah. So this is a typical truth, like a proven methodology or yeah, proven information that when you have a larger facility that can make larger components, definitely the output, yeah, the cost per part is low, and for smaller plants, the cost per part is high. And again, this break-even point, yeah, this optimal rate is still high in terms of smaller plants, and with medium plants, it drops a little, and for larger plants, it's extremely low. That's one of the reason why some of a very high use product you can never compete with the bigger guys, the sale price, because they have that advantage of larger economy of scales. So this is the truth. Yeah. So for larger facilities who have lot of cash, bigger facilities, they can manufacture a lot more quantities at lower cost per unit. But smaller plants, you can never match with the larger facilities. Yeah. So this is what this part means. And oh man, constraint is another thing. So oftentimes you have to keep these things in mind. And I think this was also rightly stated in Darshan Rane's presentation when he said. So some things to keep in mind is market. How is the market? Again, whether you are selling locally or within the same state or within the same city or nationally or internationally. And how is the market? Yeah, is it a seasonal? Is it a constant? That has to be considered. Resources, yeah. Again, do you have the right skilled people? Do you have the right equipment, tools in the right time? And again, raw materials have to keep in mind. You have to keep the financials. Always and always, this is a key thing. If you are losing money, if your cash flow is negative, then there is a problem. So you have to keep the financials in mind as well. Yeah, do you have the most advanced technology knowledge? Do you have the competency of that changing technology? If no, can you provide it to your to your, sorry, not customers? Can you provide it to your employees so that they can still work on newer technology and make the parts in the least time as well as highest efficiency as possible? And look at the policies, FDA policies, environmental policies, regulatory policies, and so on. So these are the constraints that can affect. So even though you have the most efficient process, if any of these categories are coming in between, you still can't make those. Yeah, so you strictly have to follow these categories, details of these categories, and look in, closely as necessary. And then yeah, this is how you, these are the process steps you tend to use while resolving constraint issues. That is identifying the most important constraint and always go one thing at a time. So if all of these are acting up, within all of these six, which is the highest? Suppose policy, yeah. So identify the most pressing, change the operation to achieve the maximum benefit given to the constraint. So see, like the example, in manufacturing a catheter, maybe there's some component that I'm using and the FDA says you can't use it, find an alternative, make it, show it to the FDA. So change the operation. So yeah, that's how you did, or you change the operation and trying to get approval again. And make sure the other portion of the process are supportive of the constraint, and then explore, evaluate ways to overcome that constraint, and then repeat the process until the constraint levels are acceptable levels. So get the approval from the FDA. Once you have the approval, yeah, then that constraint is zero. Then maybe move to the next one, next one, next one, and so on. So it's an iterative thing. And finally, yeah, how you evaluate. So again, there is a lot of economic, like I said, process economic, operation economic, looking at those teeny tiny detail should be considered very strongly. So is it economically feasible? So that's what, one of the concept that was mentioned yesterday was commercialization. So yeah, like, you can definitely manufacture any part. You can make a manufacturer, like if you really desire, you can study and make maybe a car as well. Yeah, or maybe something much easier. But if you are trying to form a company and try to sell it, can you make it in a profitable way? Yeah, so that is very important. Is it economical feasible? How much will it cost? So while getting the economical feasibility, what will yeah, how much time will it need to make that product, your company to make that product? Can you balance out the cost that goes in versus the sale price and have at least some yeah, at least 10, 20, 30% of profit margin? If 30% is there, oh, it's a no-brainer. You are definitely it's worth it. But if the profit margin is one, or if your profit margin is, yeah, if you are losing money to make the part, yeah, or make the product, then definitely you have to reconsider your entire operation and only introduce a product when you know that it is feasible, economically feasible. And is there any maintenance cost involved? What is the useful life of maybe the machinery or the consumable or the product, and what can be done about it? Will it be compatible with the present personal and present operations? Yeah, so again, that integration part, yeah, integrating systems mentioned by Darshan yesterday. So this is what it means. So do you have the right people? If you are getting new equipment, will it align very well within your existing operations? If not, what is needed to do? What is the investment? What is the cost? Whether it is economical feasible? So it's a like a recurring loop. You have to ask these questions again and again until you find answers and make sure it is feasible. And yeah, maybe in certain cases look for public opinion. I think, yeah, this is maybe consumer good, uh, and so on. So send out surveys if the customer like or not. Even if you have the best processes to make a product, if the customer doesn't like it, yeah, maybe there is no sale. In that case, it's not feasible. So be close to your customer, get opinions from them. So the techniques to keep in mind, I mean, here, I mean, these are the list that is yeah, that I'll usually look into. That is cost volume analysis, financial process economics, whether it is profitable, look at the decisions, have a look at the weight line analysis and simulations. We'll be talking almost all of these in the next 4 lectures. And finally, operation strategy. Yeah. So capacity planning impacts all areas of your organization. It determines the conditions under which the operations will have to function. So you should be looking at flexibility, that is agility, and that's where, like I say, modular design, lean concepts, Six Sigma concepts, agile or Scrum principles come into picture these days. Oh man, you have to constantly watch for bottlenecks and try to balance your operations as much as possible. This is a big thing, and we'll be talking a lot about it in upcoming classes, especially when we reach just in time as well as supply chain. Bottleneck is a big problem, and again, there are lots of ways to solve it. So again, even though if I see it's a big problem, it doesn't mean that it's a permanent problem. You or your management is aware of it. So it's about how you identify, how you step forward to formulate a solution and then implement a solution. Yeah. And then capacity expansion strategies are important. So expand early strategy or wait and see strategy. That is your proactive or follow strategy. Yeah, it's all about dependent upon your organization. Then contraction is sometimes, yeah, oh yeah, definitely. Sometimes again, not a preferred way, but contraction of capacity is required. And again, I think the very first example I have been constantly giving from very beginning of this class is one good example. Like I said, during our best times, we made yeah, I mean, in those days things were really well. So you are given little orders that, yeah, increase the capacity. So that's why we made a big facility that has a capacity of 130,000. But over a period of time after 2014 March, things dropped down, and yeah, demand was consistently at 60,000, 70,000 levels. So in that case, we had almost more than 50% of excess capacity. In that case, we had to contract, because we can't keep for 2 years, 3 years, 5 years, we can't keep the machine idles. It's a lot of problem. And again, if it is rusted, the machine it needs a thorough overhaul before it is qualified for operation purpose. Yeah, so that's the last point I mentioned. With that said, yeah, I think I will like to end this lecture. Thank you so much for your time and attention. I'll be uploading this video in the next 35-40 minutes, so you should be having it available by noon. And there is an associated quiz of, I would say, 15 to 20 questions. All the questions will be asked from the slide lectures as well as this video. So make sure you watch, understand it. And yeah, let me know if you have any questions. So again, I hope you enjoyed this part as well. And again, very important topic, capacity planning, capacity strategy. Yeah. So thank you so much for your time and attention. Have a very nice day ahead.